Hi, my name is Barry Burke, and I am the Chief Strategy Officer for EMC's Enterprise Storage Division. We've been talking about our enterprise storage strategy and the three components: fully automated storage tiering, federation, and active-active data access as delivered by our vPlex product family. In this session, I'd like to focus in a little bit on FAST and some of the motivation behind it, what we're trying to accomplish and where we're trying to go. The recent IDC studies have shown that information is growing much more rapidly than any of us have ever expected. And in fact, even in the past couple of years, the projections for information growth have increased from the 60% CAGR to 70% CAGR to, I think this year's study was in the 77% range. I only mention this because the simple fact is disk drives aren't getting bigger at that same speed. We're being asked to store more information in our enterprises, whether it's for retention purposes, whether it's HIPAA, where you've got to keep people's medical records for life, or the IRS, whatever it is. It's a lot of information that's being stored, and more importantly, a lot of information that's being analyzed and repurposed and utilized to build new and important learnings. So data mining and BIDW have become a major component of consumers of information. All that said, information is growing so fast, and the disk drives aren't getting bigger, and we're accessing more and more data every day. It really has become a challenge in terms of delivering solutions that meet the performance and availability requirements of our customers. Gone are the days where we just keep going and getting the next bigger, faster disk and keep delivering that. In fact, if we were on that path, if I could draw you a chart, the gap between information growth and disk drive growth is immense. So several years ago, we began looking around for technology solutions that would enable us to get over this chasm. We could foresee these days, and we really started worrying about what it is we could do. The unfortunate reality is that we do have very, very large drives that we can use at a very, very low cost. Relatively speaking, today's SATA or FAT SAS technologies can deliver us 2, 3, soon 4, 8, maybe in the next couple of years, even 16 terabytes on a single spindle. The problem with it is that that 16 terabytes does not have the same performance, or actually it has lower performance than the drive that you typically would find in an enterprise storage array, like a 300 gigabyte 15K RPM drive. So you put a lot more data on a single spindle, but you don't improve the performance. Basically, you make that capacity unusable, unless in fact no one is accessing the data. But an interesting study on our own part, by analyzing a lot of customer information and live transactions, we found that almost without fail, irrespective of how big a data set is, almost always 5% of the data is handling the bulk of the I/O. So that's what's saying if you have a 1 terabyte database, a 10 terabyte database, or a petabyte database, 5% of that capacity will be the actively utilized part of that. So this information that we're collecting is not information that's just getting parked on some side road and not being accessed. So the challenge we have is to figure out how can we service the I/O performance requirements of that 5% of the data that's constantly growing, but do it at a performance and cost level that doesn't throw the most expensive storage at everything. No longer can we just put the whole data on 15K RPM drives and hope that it works. Fully automated storage tiering, and more importantly, leveraging the technologies of flash storage and the bulk storage devices of SATA and SAS are our answer to this information growth challenge. And we've worked for nigh on 7 years building algorithms and doing analysis to figure out exactly how best to optimize and design automated storage tiering. The notion of the automated storage tiering, like I said, identify that 5% of the data, put that 5% of the data on the fastest storage possible, and then save cost by putting the rest of the information on a lower cost tier. That might be a fiber channel tier, or that might be a SATA tier. But the idea being, if we can service 50, 60, 70% of the I/Os out of the very, very fast storage, the fact that some of the I/Os take a little bit longer really will get lost in the mix. And the economies of this totally change the way we can think about storage. No longer do we just have to throw more spindles at the solution and hope that we have enough IOPS out of the drives. We can actually dial in performance by tuning how much of the I/Os land on flash how much the IOs land on 15K RPM disk drives, and ideally, how much of the unused data we can push down to lower tiers. So fast, fully automated storage tiering is our answer at EMC to this overall challenge. Now, many would say that this is all about the flash, but in actuality, finding the hottest part of applications is relatively easy. You measure how the response time is to an I/O, how long it takes, and after a very short period of time, you can figure out when you need to promote things. It's simple caching algorithms. I say simple only because I've had the opportunity to write a couple myself, and they were never simple. But the bigger challenge is to identify the data that A, is cold, that's not being accessed, and getting it out of the way. And the other one is to figure out what data is going to be needed next. And that is really the key to the overall solutions of FAST. Now, since we introduced FAST on Symmetrix back in December of 2010, FAST has been the most quickly adopted new set of technology that we've ever delivered in the history of Symmetrix, even faster than SRDF. Customers are choosing to use FAST in their development environments first, obviously, as they gain their experience. But now we're here, I'm recording this now in the end of August or middle of August. And so after only 8-9 months, we have well over 50% of the arrays leaving the factory are leaving with FAST. And we have FAST running in production in a significantly large percentage of our install base. So customers are adopting this technology and they're beginning to capitalize on it. And it does give us a very competitive and a unique competitive advantage. And that advantage comes because our engineers took the time to architect a solution rather than just build one. And I say that because when we introduced VMAX back in April of 2009, we told the world, we did a Babe Ruth, we pointed out to the bleachers and said, we're going to build this automated storage tiering on this platform. And over the next 2 years, we completed our implementation of FAST. Trust me, we didn't start back in April 9th. We started well before that. But our competition were caught flat-footed. They had never even talked about the notion of automating their tiering. And we saw competitor after competitor come to market, almost race to market, with something they called automated tiering. What we can see today, after we've been delivering our solution for 9 months, is the difference between engineering a solution and building one. To build FAST, we began by taking traces of real-life customer environments. We've modeled and traced over 3,500 production applications in customer environments. We've monitored and projected over 55 million IOs operations in these traces. And from these models and from this analysis, we've been able to determine patterns of access. We've been able to identify when a database is being expanded and when it's starting to fill up a new space in it. And we've also been able to identify locality of reference. And we used all of this kind of analysis to really design the implementation of FAST. From the block size that we use, to the algorithms that we use to track utilization, to the fact that we can identify and react to changes in less than 10 minutes. All key components, they come out of the science that went into FAST. And today, if you were to stand our product up against anyone else's, and we have presentations and materials that show how to do this, that demonstrate this already out in the field, you'll see that we can react to changes in, like I said, 10 to 20 minutes, where our competitors can take up to 24 hours to react to a simple workload change, like shifting from transaction to the nightly batch jobs. Honestly, if you think about that, reacting to the shift 24 hours later is kind of defeats the whole purpose, I would say. And we have customers, we have competitors who have best practices that say you're not really going to try to beat, you're not going to try to catch the heavy workloads. You're going to try to beat the average. Well, we never stood by to beat the average. We optimized recognizing that applications have a predictable I/O patterns, but they are unpredictable when they change, and we need to be able to react quickly. So our design allows our implementation to react in shorter period of time, and more importantly, to move less data to get bigger benefit. And that means there's less workload and overhead on the system, and also that we can give you better performance using less flash than our competitors. And since flash today is still a very expensive component, that is truly a competitive advantage. So I encourage you to take a look at FAST and to consider how it might change the world. Now, our driving factor, like I said, we're trying to get the economies and optimize the use of SATA technology and flash technology, but the real underlying motivation of this is a recognition that the system has to be able to self-tune and self-automate. And that really, right now you see fast, but that's really what's going on all across the internal of the array. Ultimately, as we look at this as a service world, we have to think about these storage arrays servicing multiple different applications, maybe even multiple different tenants, different companies, or different divisions. And this notion of multi-tenancy is an important one as we go forward. And a storage array is going to have to be able to not only differentiate and insulate different applications from each other, but also be able to provide what I call floors and ceilings to the performance as well. And this all comes out of automation. So in a sense, multi-tenancy is about putting up walls and doors and making sure that no two tenants can encroach on any other property. But what we're thinking about with FAST and some of the thinking and design that's going into it is also how we can use this to guarantee a minimum level of performance and also to set a maximum so that you can have gold, silver, and bronze and make sure that the bronze customer doesn't get more performance than they're paying for, or the gold customer never gets less performance than they're paying for. So FAST is kind of the beginning of this. It's the tip of the spear, so to speak, of the automation that's going on inside the array to prepare it, to enable it, to really be this automated platform for delivering storage services to a variety of applications, multiple tenants, and distributed in a local manner. So that's about what I want to talk about FAST for the day. And in future sessions, we'll talk about the other components of our strategy, federation and active-active with vPlex.